Hello everyone. In this video, we are going to discuss switching techniques. Switching is the process of forwarding data from one network or link to another. There are three important switching techniques that we are going to discuss: circuit switching, message switching, and packet switching. Let's look at them one by one. First, let's understand circuit switching. In circuit switching, a dedicated communication path is established between the sender and receiver before data transmission begins. There are three main phases: connection, setup, transmission, and termination. During connection setup, the required resources are reserved. Then the actual data is transmitted. Finally, after communication is completed, the connection is terminated and resources are released. A traditional telephone network is a common example of circuit switching. The main advantage is that once the connection is established, a dedicated path is available for communication. However, the major disadvantage is that the resources remain reserved for the entire connection even when no data is being transmitted. So, circuit switching can be inefficient when communication is intermittent. In simple terms, remember, circuit switching means establishing a dedicated path before communication. The second technique is message switching. Unlike circuit switching, message switching does not require a dedicated path to be established between the sender and receiver. In message switching, the entire message is treated as one unit. The message is received and stored at an intermediate node and then forwarded to the next node when the required link becomes available. This approach is sometimes described as store and forward net switching. One advantage is that there is no need to reserve a dedicated communication path. However, the entire message has to be stored before it can be forwarded. It can require a large amount of storage and intermediate nodes. It can also introduce significant delay, especially when the message is large or the network is busy. So the key point to remember is circuit switching reserves the path, message switching stores and forwards the entire message. Now let's move to packet switching. In packet switching, instead of treating the entire message as one unit, the message is divided into smaller units called packets. Each packet can contain information such as the source address, destination address, and sequence number. These packets are transmitted through the networks and are reassembled at the destination. One major advantage of packet switching is efficient use of network resources. Multiple users can share the same communication link instead of reserving a dedicated path for each connection. However, packet switching can experience delays when the network becomes congested. Packets may also be lost or corrupted and may need to be retransmitted. There are two important approaches to packet switching. The first is datagram packet switching, where each packet is treated independently and the route is not fixed. The second is virtual circuit switching, where a logical route is established before transmission and remains fixed for the logical connection. So let's compare the three techniques. In circuit switching, we establish and reserve a dedicated path. In message switching, the entire message is stored and forwarded from one intermediate node to another. And in packet switching, the message is divided into smaller packets which are transmitted through the network. A simple way to remember this is circuit, dedicated path; message, entire message, store and forward; packet, message divided into packets. These three switching techniques help us understand different approaches to transferring information through a network. Thank you.